Hey everyone, welcome to today's session, How to Find Kubernetes Reliability versus Gremlin. I'm just going to wait a few more minutes for folks to finish signing in and opening up Zoom. In the meantime, if you've come with any questions or if you just want to say hi, feel free to open up the chat, just leave a message or your question, and I'll make sure to get to them later. So for those of you who just joined, welcome. We're going to wait another minute or so to let folks finish logging in. In the meantime, if you'd like to just say hi in the chat, or if you came with questions, please feel free to submit them, and I'll make sure I get to them before the end of the webinar. We'll just wait another minute or so for folks to finish logging in. I think we can get started. So welcome everybody to this office hours session on how to find Kubernetes reliability risks. Some quick notes before we get started. If you haven't been here before, welcome. This is a monthly presentation that we do on various topics about Gremlin and about reliability. If you're ever interested in a future session that's coming up or a topic that's coming up, you can always find them at gremlin.com/office hours, and they're all free to sign up for. You can also get recordings of our previous sessions. This is an interactive webinar. I want to hear from you as much as you want to hear from me. So again, if you came with any questions or if any questions come up during the presentation, please feel free to leave them in the Q&A panel. We also have chat enabled, so if you just want to hang out and chat and say hi and talk about whatever, you're more than welcome to do that too. And again, this webinar will be recorded, so if you're not able to make the whole thing, that's totally fine. We'll make the recordings available afterwards, and we also have recordings of all our previous sessions available too. In the meantime, to introduce myself, I'm Andre Newman. I'm a senior reliability specialist here at Gremlin. I'm here to answer your questions. Again, I do have a presentation and a demo, but if you're unsure about something, if you have a question about something, or if you want a closer look at something, just feel free to mention it and I'll make sure to pick it up as we go along. So to jump right into it, or a quick look at our agenda rather, I'll start with a short presentation about the topic, about what Kubernetes risks are and how they appear in Gremlin. I'll talk a bit about how they work, how Gremlin detects them, how they show up. I'll run through a demo showing how to find and fix these risks, and then I'll leave time at the end for open Q&A. So whenever I do these sessions, I like to set some general goals just to get a better sense of what exactly we're trying to accomplish with this. So with this, it's pretty simple. We want to see what risks our Kubernetes services are susceptible to. We want to make sure that we can mitigate those risks so that our service becomes more reliable. And we want to do this automatically for any new Kubernetes services that we deploy and that we onboard to Gremlin. But more importantly, if you have any goals or any takeaways that you would like to get from this session, definitely let me know, post it in the chat. These are just the ones that are the most common that we see. But if you have any special use cases that you came here with, definitely let us know. Okay, so now to jump right into it. Let's start with the basic. What exactly is a detected risk and how does it work? So basically, detected risks are something that Gremlin detects in your environment that puts its reliability at risk. In this case, we're focused on Kubernetes, but this can be a host risk or a cloud platform risk too. So for example, for Kubernetes, did you set minimum and maximum limits on how much memory each container can use? Did you set minimum CPU requests so that your pods have enough resources allocated? Do you have things like liveness probes checking the health of your pods? And everybody's most fun error, are any of your pods stuck in a crash loop or an image pull back off? And when Gremlin looks for one of these risks and when it finds one of them, we would try to make it front and center in the Gremlin web app so that you can see that you're at risk. You can review the issue and you can hopefully use that as a means to make improvements. And we're trying to make this as seamless as possible, so these risks are all detected automatically. All you need to do is install the Gremlin Helm chart or the Kubernetes manifest to your cluster, and all the rest should happen without any other input or any changes to how your cluster operates. I'll show a bit more about how that works in practice a bit later. So looking a bit about how it works under the scenes, it's actually pretty straightforward. First, on your end, you just deploy the Gremlin agent to your cluster as that Helm chart or as that Kubernetes manifest. The agent is just a daemon set. So essentially, that means it runs one agent on each of your worker nodes. It also runs a main agent on the control plane node. These are responsible for communicating with Gremlin's backend servers, but by default, we don't usually run tests on control plane servers. You can configure that using tolerations if you want to, but keep in mind that does come with some risks, so just be mindful of that if you do decide to do that. It can be useful for things like testing split brain issues or making sure that you have enough control plane nodes for backups, but just to keep that in mind, that's something you have to enable yourself. So basically, how this works is once you install the agent, it has read-only access to the Kubernetes API. This is so it can see configuration details for services that you're onboarding to Gremlin. Again, this is read-only access, and it's limited only to configuration details for the services that you specify. We're not making changes, reading secrets, or doing anything like that. So for example, let's say you're running an Nginx service. The Gremlin control plane asks the agent to query Kubernetes for details about your deployment. So for example, what state is it in? How many pods does it have? Does it have a liveness probe defined? Things like that. That agent will then send back a report to Gremlin's control plane that simply says whether the service mitigated the risk, is vulnerable to it, or the risk doesn't apply. Essentially, all we know is whether the service is at risk or not and the last time it was checked. Again, I'm not looking to collect excessive data, I'm not trying to poke and prod at your services. We just want to check them against a pretty basic set of conditions and give you that report on whether essentially they pass or fail. All right, so what risk does Gremlin actually detect? We split these into three different categories just to make it easier to show, but that doesn't necessarily mean that they're weighed differently. I also added a link to our documentation site at the top there, which has a bit more information on each of these. There's kind of a bit to cover. So again, if you have questions, please don't hesitate to leave a comment in chat or the Q&A as we go. So kind of going from the bottom up, we have three pod level risks. One is init container errors. So init containers are basically containers that run before your main application container starts. It might do some setup like downloading data or copying data off of a NAS or something along those lines. Essentially, it starts, it hands off to the main container, and then it ends. Now, if one of these fails, that could be an issue because that may mean that something wasn't set up properly for your main container. So this detected risk checks to see if any of those init containers failed and reports that back up to you. Next is non-uniform application versions. So if you have multiple replicas of a pod or container running, which most likely you do if you're using Kubernetes, we look to ensure that they're all using the same image version. Yes, that does mean that you can't use dynamic tags like latest. And the reason for that is that if you deploy an instance or a replica rather on one day, or even let's say at one time during a day, if that image gets updated later, then any replicas you deploy after that point will use a different image, and therefore your uniformity will be off. They'll become non-uniform. Typically, this isn't a huge problem, but it can lead to all kinds of conflicts and troubleshooting headaches. So we recommend just avoiding it altogether and then just pinning your image to a specific version or tag, and then making sure that all of your replicas adhere to that same version. And then the classic image pull back off and crash loop back off errors. This is a problem where in your container, sorry, let me start that over. This is when a problem in your container manifest or registry prevents you from running or even just creating the pod. Crash loops are typically caused by the software inside the container not starting up properly, or while image pulls are usually caused by whatever node it's running on not being able to reach the registry where the image is hosted. In both cases, you'll want to check the pod logs and pod definition to see what errors were logged, but this detected risk just makes that more apparent to you so they at least know that it's a problem. So stepping up a bit, let's look at deployment level risks. So first is missing memory requests and limits. The reason we focus on both of these is to ensure that your pod not only has enough resources to start, but that they get scheduled onto nodes with enough capacity. And the limits are there to prevent memory leaks or to prevent your pod from expanding too much and using too much memory. And the reason why these are important is because when Kubernetes schedules a pod, it typically just looks to make sure that there's enough room on the node that it's going to schedule it onto. And if there isn't enough room for that pod, it'll actually hold back and wait until there's a node available. So by setting requests, you're essentially saying this pod requires at least this amount of memory available. So that will help Kubernetes schedule it to the right node. And if there isn't one available and you're running on the cloud, hopefully scale up your cluster vertically so that, or horizontally rather, by adding an extra node so that you get that extra capacity. And again, the limits are just there to make sure that if your pod, something goes wrong with it and it has a memory leak or something, it doesn't just keep consuming memory and break your whole cluster. And the same logic applies to CPU requests. Again, Kubernetes uses information to determine which worker node to schedule your pod onto. Without it, it's more or less it's more or less a best guess. And while CPU is a bit more forgiving than memory, we still recommend addressing it because it can still be a critical issue if left untreated. And lastly, for deployments, we look at to see if you have liveness probes enabled. This is so that if a pod becomes unresponsive, Kubernetes can just automatically restart it for you. Otherwise, you might have to go in and restart the pod yourself. So now we get to the top level, which are cluster level risks. And while there are just two of these, we still try to aim for the most relevant, the most common, and the most important ones, starting with no availability zone redundancy. So this just checks to make sure that your cluster has nodes in at least two different availability zones. So for example, if you're on AWS, you might have a node in US East 1, one in, actually, I'm sorry, those are regions. US East 1A, US East 1B, or US East 1C. This is so that if one of these zones becomes available, which does happen even with major cloud providers, nobody's immune to failures, unfortunately. If this does happen, you do still have some nodes to fall back to. Now, the convenient thing about managed Kubernetes services like EKS or Azure Kubernetes services is that they'll often abstract away the control plane nodes so that you only have to worry about the worker nodes. You only have to concern yourself with deploying enough worker nodes across your different AZs to provide that redundancy. But if you manage the cluster yourself, or if you deploy on-prem, or if you just want to have full control over the cluster, you'll just want to make sure that both your worker nodes and your control plane nodes are AZ redundant. And the way we check this in Gremlin is pretty simple. We just look at your cluster and verify that there are at least two unique zone tags that the agent returns back. Pretty straightforward, but still gives us a pretty good sense of whether or not you're redundant. And lastly, unschedulable pods is exactly what it sounds like. We look for any pods that can't be scheduled onto a node. They might have that unscheduled status or that pending status that pods tend to get stuck in when Kubernetes can't figure out where to deploy them or how to deploy them. While this might sound like a pod risk on the surface, not being able to schedule pods is almost always a problem with the cluster itself. A lot of times it's due to unavailable capacity, maybe a node failed, maybe you have misconfigured taints and tolerations, or it's Kubernetes. There could be a million different reasons as to why it happens, but it almost always indicates a problem beyond the pod and with the cluster itself. Quick solution for this is if you're on the cloud, just scale vertically, add an additional node, and see if Kubernetes can schedule your pod onto that new node. That'll tell you whether or not it's a capacity issue. So again, that was a whole lot to cover. We have a lot more detail on these in our documentation on the link up above, but you have my time and attention right now. So if you have any questions about any of these in particular, again, feel free to use that chat or the Q&A panel. I'm happy to answer them. In the meantime, though, I'll switch over to a quick demo about what this looks like in practice. But first, before I do that, I'd actually like to show you an example Kubernetes manifest. Oops, sorry, I just lost my place in my notes for a second. All right. First, I wanted to start off with look at a Kubernetes manifest. I promise you we won't go through the whole thing. There's just a couple lines that I wanted to point out specifically. So this one you might have seen before. It's the default stateless demo that the Kubernetes documentation provides. It just runs a pod running Nginx and it has it up, scaled up to 2 replicas. But the main thing that I wanted to show off here are these annotations. So Like I mentioned before, the way you deploy Gremlin to Kubernetes is you install our Helm chart or our Kubernetes manifest, and then the agent runs in the background and looks at the Kubernetes API to see which services that it needs to monitor. While it's doing that, it will look for pods or deployments or daemon sets or other resources that have these annotations. We have three in total, but the two in particular that I want to show off are the service ID and then the tags one. The service ID essentially tells Gremlin, this is the name of the service. This is how I want you to call the service in the Gremlin web app. This is how I want to refer to it. We recommend setting it to the same name as the deployment or the resource itself, but again, that's totally optional. You can call it whatever you want. Naming it the same thing is just easier for reference. The second one are tags. And if you're new to Gremlin or if you haven't used tags before, tags are essentially just metadata that Gremlin uses to help with targeting and categorization and things like that. Gremlin does collect some metadata automatically, like what zone the resource is running in, what namespace it's running in, the deployment name, of course, and also the name of the cluster. But here you can add your own custom one. So for example, I have two key value pairs here. One tells it that it's just part of this demo application. So if I have other deployments that are part of the same application set, I can add this here too. And then this one says that we're running in a staging environment. And this one's actually behaves a little differently because if you tell Gremlin that this is running in a production environment, Gremlin will actually display a banner over the service in the web app, like a bright orange banner as sort of a warning to say, hey, if you're going to run tests on this, just be aware that it's in production. So it just gives you the extra bit of safety and that extra little gut check before you actually go run the app, before you go run a test, excuse me. All right, so that's enough looking at YAML. I'm going to switch over to the web application and we can take a look to see what it looks like in person. Typically, when you deploy the updated manifest with the annotations, it takes a few minutes for the service to appear, but I've already got it configured. I did that in advance, so we don't have to worry about taking time up here. So this is my Nginx service that I just showed you. You can see that I have my two tags here, and you can see that I've already got some risk detected. So let's click into that. So right away, we can see that we have four detected risks. If I click into them, I get just immediately a list of all the risks that the service is susceptible to and their status. So you can see that the four that I have at risk are I haven't set my memory request, I haven't set memory limits, I haven't set CPU requests, and I haven't set liveness probes. The good news, though, is that I have mitigated quite a lot of them. So the image is running successfully. The init container is working. Actually, there is no init container for this one, so it just passes automatically. Um, I don't have any unschedulable pods on my cluster. And then all the replicas are running the same version of Nginx. And I do have replicas running in two different zones. So these just confirm that, an assumption that I had earlier about whether or not my deployment was zone redundant. This is a really good way to just come in and quickly confirm that, yes, that is actually working the way I expect, and Kubernetes is actually deploying these zone redundantly. But let's take a look at one of the ones that I didn't hit. So for the liveness probe, for example, if you want to learn more about what this means and how you can fix it, all you have to do is click on it. Gremlin comes with the documentation built in that explains what this is. In this case, I haven't set this spec containers liveness probe attribute to configure a liveness probe. Gremlin explains why it's a risk and also how you can go in and fix it. And in some cases, we do link to the original documentation. So you'll see a lot of links to the Kubernetes documentation here. I don't think there is, actually, sorry, there is one here. It's just a little difficult to see. But you can just come here, click on that, and just get immediately referred to the documentation that tells you how to enable it. So if I do go in and fix this, let's say I go in and add a liveness probe, I can redeploy my service, and then after a while, the Gremlin agent will detect that there's a liveness probe defined. It'll report that back up to Gremlin's backend servers, and then I'll see this change from at risk to mitigated, and that'll result also in the increase in my reliability score. So really the good thing about detected risk compared to regular tests is that they're fully automated. They're happening behind the scenes. They're happening continuously. Gremlin is continuously evaluating them to see if your service is susceptible to them. And if not, then you get that nice green mitigated and increase to your reliability score. But if they are, you can always just come here and click on any one of these and get more details about how you can go in and fix them. So we have a bit of time, so there's one last thing that I want to cover. If you're curious, you might be wondering, okay, so we have all these detected risks, but where do they come from? And can you pick and choose which ones you want to evaluate? And the answer is yes. And the way that we do that is by creating what we call a test suite. Basically, a test suite is a group of reliability tests and detected risks. So let's say I go back to the services overview page. We have our detected risks there, listed just in a separate card. But beneath that, we have all these different reliability tests, like testing CPU, testing memory, testing host and zone redundancy, things like that. These all come from a test suite. And again, you can go in and configure test suites. You can clone them to create your own, and you can also create your own from scratch. But I'll show you a quick look at what that looks like if you were going and editing it yourself. So I have a bunch of test suites already configured. The one that we use by default, that Gremlin uses by default, rather, is this Gremlin recommended test one. These others are ones that I've created or that other members of my team or other members of my organization have created. So you can click on these two and see what your teammates have come up with or what they're working with. But let's click into this default one. And the first thing that you'll see are the different teams that it's assigned to. So a test suite can be assigned to one or more teams. When you assign them, it replaces their existing test suite, and so it replaces all the existing tests as well. Um, the good news is that when the old test suite gets replaced, we save your scores so that you don't lose them. So if you decide later on that the new test suite isn't quite working out or it isn't meeting your needs, you can always switch back and get those old scores back. So don't worry, we don't delete them or anything. They're still there. They're just hidden essentially. But the main thing I want to show you here are these test and risk tabs. So test is where you pick and choose what reliability test you want to run. That's a whole separate office hour session, so I'll hold off on going that into detail. But if you look at risks, this is where you can pick and choose which risks are part of this test suite. So again, by default, we include all of the ones that are available. If we want to ignore certain ones, then the way you would do that is by creating your own custom test suite. In this case, you can just clone this one. And then if you click next, we have a tab where you can edit which risks are involved. So let's say I don't care about AWS. I'm not running on AWS, so I don't want to detect any AWS risks. You can just check off all the ones that are AWS relevant, move them to ignored column. And then once you save and assign this new custom test suite, those risks just won't appear in the list at all. Even if you have services running on AWS, they won't be listed at all. They'll just be removed entirely. So that's one way that you can ignore them. The sort of asterisk next to that is you should actually, or rather, we recommend leaving all of the risks enabled. And the reason for that is Gremlin has logic that will determine whether or not a risk is relevant for that service. So for example, I just showed you that I have a bunch of, or rather that Gremlin has a bunch of AWS risks that it evaluates by default. Because my service wasn't running on AWS, Gremlin was able to figure out that, okay, these AWS risks aren't relevant, so I just shouldn't bother evaluating it for this service. So it just pulled them out automatically without me having to ignore them. So again, you can come in and you can manually ignore certain risks, but at the same time, if you're worried that a risk that isn't relevant to a service will show up, you don't have to be. We'll evaluate that, we'll figure out whether or not it's relevant, and then we'll just exclude it from the score automatically. What this is useful for is, let's say your company doesn't care about CPU requests at all. You can just add that, and then that means it just won't check to make sure that all of your deployments have CPU requests configured. So again, this is a good way to just come in and quickly pick and choose which risks that you want to have included and exclude the ones that you don't. All right, so again, that was a lot to cover. If you have questions or if you have a comment that you'd like to leave, you're more than welcome to put in the Q&A or the chat panel. But in the meantime, I'll head back to my slides for a quick wrap up. So if you've seen how detector risks work, you've seen a bit about how to configure them, how to remove them if you'd like to, or how to add in extra ones. There are a couple ways to get started. First, if you're a customer, that's awesome. You can just jump right into the product and you should already have access to all of this. All you have to do is either add those annotations to your Kubernetes manifest or add your Kubernetes service directly manually, and we'll be able to evaluate those detected risks for you as soon as you add it. If you're not a customer, then welcome to Gremlin. You can get a free 30-day trial by going to gremlin.com/trial, add your service. Immediately, you'll get the detected risk report so you can pick and choose, or rather, see which risks you might be susceptible to. And if you found this session valuable and you want to see similar sessions like this, or if you have an idea for a topic that you'd like us to cover, you're more than welcome to either sign up for a next session at gremlin.com/office hours or use the contact form on our website or after this webinar to put in your suggestions. And as a heads up, if you logged into your Gremlin account and you don't see services or dependencies enabled, just reach out to your Gremlin admin or your account rep, and they'll be able to get you started on that process. All right, so that was all for my side of it. Do we have any questions or comments? I see one comment from Peter. Hi, Peter. Welcome. Glad you're able to join us. Let's see, is there anything else? Oh, okay, well, I'm glad the presentation was super clear and easy to understand. At least I hope that's the case. Oh, okay, in that case, then we can wrap up a bit early. If you do end up thinking of something that you want to ask that maybe that didn't come up during the presentation or you forgot to ask about, that's totally fine. Always feel free to reach out to us at gremlin.com/contact. We'd love to hear from you. In the meantime, though, you have some choices for testing this out yourself and for giving it a try. If you're new to Gremlin, hopefully you'll sign up for that trial. And again, even if you don't stay with us past the 30 days, you'll still get those detected risks. You'll still be able to find any risk in your environment and you'll still get that report. So at the very least, just give it a shot. Again, we'd love to see you at any of our future upcoming office hours sessions. These are for you. So let us know what you'd like to see, what you'd like to hear about, what you'd like us to demo, and we'll make sure to do that. In the meantime, thanks so much for joining us today. Hope this was informative and have a great rest of your week. And for those who celebrate, happy Easter. Take care.